Hi everyone. In this video, we're going to be doing A Level Maths 9709, Paper 33, Pure Maths 3, October, November 2025. This paper is 1 hour 50 minutes long, so we'll try to finish within the time limit, so let's get started. Okay, so for the first question, we are told to solve this modulus inequality. Okay, so to solve this, since both sides of the equations are modulus expressions, we can square both sides. We're making use of the fact that if the modulus of A is more than the modulus of B, it's also the same as A squared being less than B squared. So yeah, that's the property we're using. So let's start by squaring both sides. So on the right-hand side, we have to spread the index to both the 3 and the 2x minus 1. So that would basically be 3 squared, which is 9, times 2x minus 1 squared. So, okay, actually, let's just keep it as 3 squared. Let's not expand it. So now we're going to move everything over to the right-hand side. So this would be 3x plus 2 squared minus 3 times 2 minus 2x minus 1, whole thing squared less than 0. Okay, so let's just expand everything inside this bracket in here. So we'd have 3x plus 2 squared minus 3 times 2x, that's 6x. 3 times negative 1, that is negative 3, whole thing squared less than 0. Okay, so now you should realize that this is actually in the form of a squared minus b squared. And what do we do when you have something like this? Well, we can factor it into a minus b times a plus b. So that's what we're going to do here. So our a is 3x plus 2 and b is 6x minus 3. So a minus b would be 3x plus 2 minus 6x minus 3. And then a plus b would be 3x plus 2 plus 6x minus 3 less than 0. So let's simplify everything inside the brackets. So expand out the negative sign. So negative 6x, negative 1 times negative 3, that's positive 3. And this one, just add up everything. So 3 plus 6x, 9x plus 2 minus 3, that is negative 1. So simplifying this bracket, you would get 2 plus 3, which is 5, minus 6 plus 3x, which is minus 3x. So 5 minus 3x times 9x minus 1 is less than 0. So this is our final factorized inequality that we have to solve. So now we have a quadratic inequality. And to solve such an inequality, we should first see what shape this expression would have if we plotted a graph of this expression. So if you realize, if you multiply negative 3x times 9x, you would get negative 27x squared. So since our x squared term has a negative coefficient, the graph would be like this. It would be a sad face graph, as I like to call it. Okay, now we should put our roots in here. All right, so our roots is going to be 1 over 9 and 3 over 5. Like if you equate each of the factors to 0 and solve for x, you would get those answers. So 3 over 5 is 0.6 and 1 over 9 is 0.11. So this is 1 over 9 And this is 3/5. So 3/5 is 0.6. So 3/5 is more than 1/9. Okay, now we look at the region of interest. So that would be based on our inequality sign. So here it says less than 0. We need to look below the x-axis. So below the x-axis, this means that this would be our region of interest. And hence we can say that x is less than 1/9 and x is more than 3/5. So yeah, this would be our final answer for this first question. Let's head on to the next question. Okay, so for this question, we need to find the quotient and the remainder when this polynomial is divided by x plus 1. Okay, so this is basically a very basic polynomial division question. So first things first, to start off any polynomial division, you write your expression that you're dividing, like all the terms. So we have the x to the power 4 term, so 3 times x to the power 4, and we don't have x to the power of 3, so we will add that and put 0 as the coefficient. Okay, we'll have a x squared term, which is minus 2x squared. And then for the x term, that's also 0x because there is no x term. And finally, we should put a constant term, which is 0. So that's what you do when you don't have like the missing, when you have like missing terms. So in this case, our missing terms are x cubed, x, and the constant term. So for those, just put your coefficient as 0. Okay. And yeah, we divide it by x plus 1. So that's our divider. Okay, so now we're ready to start. So to begin, we should expand x plus 1. I mean, we should multiply x plus 1 such that the first term becomes 3x to the power 4. So we can multiply x plus 1 by 3x cubed. So 3x cubed would go here, right above the x cubed term. So this would be minus 3x to the power 4 plus 1 times 3x cubed, which is just 3x cubed. So 0 minus 3x cubed, you get minus 3x cubed minus 2x squared. Okay, we can just bring these two down. Now, we do the same. Now we need to multiply something that makes our x term minus 3x cubed. So for that, you need to multiply minus 3x squared. So this is what you multiply by, minus 3x squared. Again, it should be above the x squared term, all right? So this is minus 3x cubed minus 3x squared. So again, this would be 0 and minus 2x squared minus negative 3x squared. That's the same as 3x squared minus 2x squared. You get x squared. Okay. So we keep on doing this until we get a remainder where the degree is less than the divisor. So x plus 0x, just, copy down the following term. Okay. So now we should minus x squared. So to make this term x squared, just multiply by x, which would be here. So multiplying x, you get x squared plus x. So you get x squared minus x squared, which is 0, and 0x minus x, which is minus x. Okay, we're almost done. Let's carry down the last term, which is a constant term. And for this, you need to minus negative x. And to make this negative x, you multiply by negative 1. So multiply by negative 1, you get negative x minus 1. So 0 minus negative 1, you get 1 as your final remainder. So this is where we can stop. And hence we can conclude that our quotient is this whole polynomial up here. So the quotient is 3x cubed minus 3x squared plus x minus 1, and our remainder is just 1. So yeah, these two will be our final answers for this entire question. Let's head on to the next question. Okay, so for this question, we are told to solve this exponential question, and our answer should be given in this form, ln m over ln n, where m and n are integers. Okay, so to do this question, we're going to collect all the x terms on one side and the rest of the terms on the other side. So let's start. So copy down the equation first. So to make the separation of x terms and non-x terms easier, we are going to split the left-hand side first. So using our law of indices, we know that a times n minus m is the same as a to the power of n minus a divided by a to the power of n. So hence, similarly, we can write this as 2 to the power of 3x over 2 to the power of 4 equals to 3 times or over 5 to the power of x. Okay, now we can just cross multiply, then we would automatically separate all the x terms and non-x terms separately. So you get 2 to the power of 3x times 5 to the power of x equals to 3 times 2 to the power of 4. Okay, so to just make this in terms of x, we can make use of this law where it says if you have a to the power of b times c, you can actually separate this. So you can put a bracket and you can rewrite this as a to the power of b bracket to the power of c. So in this case, we can put a bracket between our 3 and x, then you would get 2 to the power of 3 to the power of x. So 2 to the power of 3, that is 8. So I can rewrite this as 8 to the power of x times 5 to the power of x. And the right-hand side, just press your calculator. You'll get 48. Okay, so now we are left with this expression. What do we do with it? Well, you can see they have the same power, so we can use our law of indices again. So if we have a to the power of n times b to the power of n, we can combine them together since they have the same power as a times b to the power of n. Okay, so this would just be 8 times 5 to the power of x equals to 48. Then you will get 40 to the power of x equals to 48. Okay, now this is where we take ln on both sides. So we take ln 40 to the power of x equals to ln 48. And now we're left with this on the left-hand side. So we can use a product rule, which says if you have ln a to the power of b, you can bring down b over here, then you get b times ln a. So similarly, this would be x times ln 40 equals to ln 48. And just divide both sides by ln 40, you would get our final answer, which is ln 48 over ln 40. Yeah, so this would be our final answer for this entire question. And if you want to check if you're correct, just substitute this exact answer onto both sides of the equation and see if they match. So yeah, with that, yeah, it satisfies all the conditions. Yeah, we can head on to the next question. Okay, so for this question, we are told on an Argand diagram, we need to shade the region whose points represent complex numbers z, which satisfy both these inequalities. So the first one is modulus of z plus 2i is less than or equals to 3. And the second one is modulus of z plus 2i less than or equal to modulus of z minus 2 plus 4i. Okay, so for the first inequality, we have a whole number on the right-hand side, and on the left-hand side, we have our modulus of z plus whatever complex number. So if you get inequality in that form, or more generally, if you get an inequality of z minus a plus bi, so minus bracket a plus bi, less than or equal to r, then this would represent a circle with the center A, comma B, and radius R. So in our case, this, when you factor out -1 from the 2i, you would get z minus -2i less than or equals to 3. So our coordinates for the center would therefore be 0, so since there's no real part, so no x coordinate is 0. Okay, so sorry for the delay. As I was saying, the coordinates of the center of the circle would be 0, comma, -2. Yeah, so, and the radius would be equals to 3. So this is going to be a circle, and our inequality sign, since it is less than n equal to, it would include the entire interior of the circle. So it includes the circle as well as the boundary of the circle. So everything except outside the circle. Okay, and as for this, well, this is a perpendicular bisector between 2 points. So what those 2 points are, again, factor out -1 from the complex number. So you get z minus -2i, the modulus of that less than or equal to z mod -2 minus 4i. So the points which we are concerned with that you want to sketch the perpendicular bisector of is 0, since there's no real part for this one, comma, -2, and for this is 2, that's the real part, and comma, -4. So these are the 2 points that we want to construct the perpendicular bisector of. And since the sign is less than or less than or equals to, the region would include everything above the perpendicular bisector. We'll see that how, okay? So, okay, you know what? For this, we can actually like solve for our equation. So you can just substitute z equals to x plus iy. So yeah, we'll get z x plus iy plus 2i less than or equals to x plus iy minus 2 plus 4i. So I'll just separate the real and imaginary parts. So x plus 1, y plus 1 times I. And this is less than or equals to x minus 2 plus y plus 4i. Okay, so this one, we just have to find the modulus of that. So you just square the real and imaginary part, and you take the sum of the squares and you square root. So x squared plus y plus 1 squared less than or equals to square root of x minus 2 squared plus y plus 4 squared. So we can remove the square root and just expand everything out. So we get x squared plus y squared plus 2 times y times 1. You get plus 2y plus 1 squared. Less than or equals to, for this one, will be x squared minus 2 times x times 2, which is minus 4x, plus 2 squared, which is 4, plus y squared, plus 2 times 4 times y, you get y, 8y, plus 4 squared, which is 16. So let's see any common terms. We cancel them out. So y squared, you cancel. X squared, you can cancel. Okay. Okay, let's just move all the y terms to the left hand side. So 2y minus 8 less than or equals to, so this one you can move to the other side, you get minus 4x plus 4 plus 16 minus 1. So you get, wait a minute. Two times 4 times y. Hmm, wait a minute. Hmm. Let me see if I made any careless mistake. Uh, okay, I didn't make any. Something's wrong. Minus 8 plus, that's minus 6. Okay, give me a while. Okay, so I realized my mistake. So instead of putting 2 here, I put 1. So hence my expansion was wrong on this side. So this is supposed to be 4y plus 2 squared, which is 4. So, okay, let me just cancel this. So 4, 4. Yeah, we can also cancel that out. Then we'll have 4y less than or equals to negative 4x plus 8y plus 16. Okay, so we move the 8 to the other side, you get negative 8y plus 4y is negative 4y less than or equals to negative 4x plus 16. So you divide, oh God, that's a lot of space wasted. Okay, so you divide both sides by negative 4, you get y, and the inequality sign flips. Y is more than or equal to x minus 4. So this is the equation of our perpendicular bisector that we need to sketch. Okay, so I know it seems long, but then in the exam, please do it in like a rough space, or you can do this in pencil and then erase it when you need to draw your Argand diagram. So yeah, for me, I need to work with this limited space that I created. So this will be a real axis. This will be our imaginary axis. So our circle, the coordinates is 0, negative 2. So negative 2, I will let it be here. Okay, so this is negative 2, this is negative 1. And this is 1, this is 2, and this is 3. This is 1, this is 2, this is 3. Yeah, in the actual exam, please get a ruler and don't like draw freehand like me. Okay, so yeah. So the radius is 3. So 1, 2, 3. 1 point will be here. 1, 2, 3. 1 point will be at the origin. 1, 2, 3. 1 point would be here. And finally, okay, never mind, somewhere here. And finally, 1 point would be 1, 2, 3. So this is negative 5. It'll be here. So now we just join up all these. So since the boundary is included, this wouldn't be a dotted circle. So just join them up. Yeah, it doesn't look really good. Okay, you know what? Let me redo that. Okay, yeah. Okay, let me redo. and you would get this. Yeah, I know this isn't perfect, but it's the best, right? So this is inside the circle and the boundary. And now let's draw the perpendicular bisector. Okay, so it would get y more than or equal to x minus 4. So y equals to x minus 4, we need to sketch that. So our y-intercept would just be 0 minus 4, which is negative 4. So somewhere here. And our x-intercept would be x equals to 4, which is right here. Okay, so let's join those two up. Yeah, so this is a perpendicular bisector. And if you do draw a perpendicular bisector, remember to draw the points that you're drawing the perpendicular bisector with respect to. So in this case, it's this point here and 2 comma negative 4. So 2 comma negative 4, so 2 is here, negative 4 is here. So these are the points that we are drawing respect to. Like if you use the traditional way of using a compass and drawing your I forgot the name, but yeah. So you can also use that way to draw instead of all this. So yeah, inside the circle and more than. So it's above the line, above this line and inside this circle. So this would just include this whole region in here. So yeah, this would be a final answer for this entire question. Let's head on to the next question. Okay, so for this first part, this question, we need to show that this identity is true. So this whole trig identity is true. Okay, so let's start with the left-hand side. It looks more complicated because this one we just have to express in terms of sign. So cos for x plus 2 sine square x minus 1. Okay, so our goal is to make everything in here in terms of sine only, so sine x only. So to start, we need to manipulate this cosine for x. So this cosine for x, we know it's just 2 times cosine 2x, so we can write it as that. So this is cosine 2 times 2x plus 2 sine square x minus 1. So cosine 2a, we already have like a formula for that. So we have 3 formulas. So since we only want everything to be in terms of sine, we're going to choose this one, 1 minus 2 sine square a. So 1 minus 2 sine square, our a is this, so 2x plus 2 sine square x minus 1. So the 1, they cancel out, 1 minus 1, and we only have minus 2 sine squared 2x plus 2x. I'll just swap the terms because I don't like seeing the negative sign in front. And to re-express sine 2x squared, in terms of sine x, let's look at the sine double angle formula. So given here, sine 2a equals to 2 sine a cosine a. So this one would just be 2 sine square x minus 2 times sine 2x, that is 2 cos x sine x whole thing squared. Okay, so this would be 2 sine square x minus 2 times. So this power, we have to spread it to every term, including 2 cosine x and sine x. So this would be 2 squared, which is 4 times cos squared times sine squared. Okay, now let's expand everything out. 2 sine square x minus 2 times 4, which is 8 cosine square x times sine square x. So we only have a sine square term to manipulate. So for that one, we can use a classic identity, cos square plus sine square equals to 1. So cos square, we can make it the subject, then we'll get 1 minus sine square. Right, so 2 sine square x minus 8 sine square x times cos square x, which is 1 minus sine square x. Yeah, so expanding everything, you would get minus 8 sine square x plus 8 sine square times sine square, that is sine to the power of 4x. Okay, and now just simplify everything, collect all like terms. So we have 8 times sine to the power of 4x plus 2 minus 8, which is minus 6 sine square x. Yeah, so that would be our final answer. And the exact answer we need to show, so we can write shown in here. So yeah, this would be our final answer. For the first part, let's head on to the next part. Okay, so for part B, they told us hence. So we need to use our answer from the previous part. We need to solve this trig equation for this domain of x, which is between 180 degrees and negative 180 degrees inclusive. Okay, so first things first, we realize the left-hand side of this equation is exactly the same as the identity that we proved. So we can directly just substitute this result from part A into our equation. Yeah, so this is 8 sine 4x sine to the power 4x minus 6 sine square x equals to 0. Okay, and then we can factor out 2 and sine square since both of the coefficients are even. So 2 sine square x we can factor out, and you would get 4 sine square x minus 3 equals to 0. And then you would have 2 sine square x equals to 0. And ultimately, you would end up with sine x equals to 0. And this one, with more complicated, 4 sine square x minus 3 equals 0. So you'll have 4 sine square x equals to 3. Sine square x equals to 3 over 4. And sine x, which is plus minus square root 3 over 4, which can be further simplified to plus or minus square root 3 over 2. So yeah, we have 3 values for sine x. Okay, so now that we have a sine x, let's draw our unit circle and see which which quadrants our domain for x covers. So yeah, it's a unit circle. So maximum is 180. So this is 0. So from here all the way to 180, and also goes the other direction all the way to negative 180. So yeah, this is our whole domain of x. All right, so now let's just label all the axes. So this one is A. So is it positive or negative for sine x? This is positive for sine x. This is also positive for sine x. This is negative for sine x. This is also negative for sine x. Okay. All right. So yeah. Let's start with sine x equals to 0. So to solve this, you just take sine inverse 0. You press your calculator, you would get 0 degrees. However, there's also another answer that's in our range. and that is 180 degrees. And to know this, you need to draw out your sine x curve. So sine x starts with 0, and then this one, 1, it's pi over 2 or 90, and this one is pi, which is 180, and eventually 2 pi. So these are the 3 points in which sine x is equals to 0. And okay, let's see if negative 180 counts. Yep, it counts as well. So you get x is equals to negative 180 degrees. So these are our first three answers for sine x equals to 0. Now we're going to solve sine x plus or minus square root 3 over 2. So to solve that, we're going to solve them separately. So sine x, let's solve the positive one, square root 3 over 2. So since it's positive, this x can only be either in the first quadrant or the second quadrant. So for the first quadrant, it would look something like this, with just a basic acute angle. Okay, so the acute angle, just to get it, just take the inverse sine of square root 3 over 2, and you get, you don't forget to set your calculator to degree, because that's the units that they gave us our domain in. Okay, we got a perfect answer, 60 degrees. Okay, so to find the second value of x in our second quadrant, we need to know that that angle looks like this. So it's a positive obtuse angle. And to get that, we do 180 degrees minus this basic angle, which is just sine inverse square root 3 over 2. So this is x equals to 180 degrees minus sine inverse the modulus of whatever sine value is. So this is just going to be 120 degrees. So these are our two angles for sine x equals to square root 3. Let's do for sine x equals to negative square root 3 over 2. Okay, so since here our sine x is negative, x would cover our third quadrant and fourth quadrant. So, and those angles, in both of those quadrants, both of our, all the angles are negative, so they go clockwise instead of anti-clockwise. So let's do for the fourth quadrant first. So to get for the fourth quadrant, just, we need to know the angle looks like this. So it's a negative acute angle. And to get a negative acute angle, just take negative sine inverse square root 3 over 2. You'll get negative 60 degrees. And then to get the one in our third quadrant, okay, we need to know what it looks like. So it's just an obtuse angle in the negative direction. And to find it is basically the same way. Just take this basic angle and add negative 180 degrees. Okay, so this is just going to be minus 180 degrees plus the basic angle sine inverse square root 3, sine inverse square root 3 over 2, and you would get minus 120 degrees. So these would be our two angles for sine x equals to negative square root 3 over 2. So yeah, these would be our final, how many is that? For 7 angles for this question. Okay, if you want to check whether you got each of the angles correct, just substitute directly into the equation and see if you get 0. Yeah, so with that, let's head on to the next question. Okay, so for this question, we are told to find the exact value of this definite integral. Okay, so first things first, we notice that this integral is a product of two functions. And what do we do? like by default, when we see a function like this that we have to integrate. So we should automatically think of integration by parts, okay? So let's write down our integral. Let's copy it down. Okay, so how do we get started? So let's take a look at the formula for integration by parts. Okay, yep, it's right under here. So this is our u. So integration by parts states that the integral of u times dv dx is equals to u times v minus the integral of v times du dx. So one of the variables we need to choose to let it be u, and the other one has to be dv dx, which we have to integrate. So to choose u, we have to remember this rule, Liet. Okay, so Liet stands for log. So your logarithm functions like a ln, and then I is for inverse trig functions. So for us, we only have tangent inverse, and A is for algebraic. So like your polynomial x cubed plus 2x squared. Yeah, so anything, the x above anything, basically. And then T is for trig functions, and then E is for exponential functions. Okay, so how we do this is we circle the types of functions we have. So in this case, we have the algebraic function as well as the trig function. And whichever comes first in our list would be u. So in this case, algebraic comes first before trig. So we're gonna let x squared become u. So u would be x squared, and sine 2x would be dv over dx. All right. So now let's figure out du dx. So differentiating, we get 2x, and v, just integrate sine 2x, you would get minus half cos 2x. Because integrating sine x, you would get negative cos x, and for integration, you need to divide by the derivative of the inner function, which in this case is 2x, so you divide by 2. So that's how you get minus half cos 2x. Okay, so let's begin. Okay, so this integral, I have a feeling we need to do integration by parts twice in here. Okay, so you multiply u and v first. So don't forget to plug in your limits later. So this x squared times negative half cos 2x, limits is pi over 6 and 0, minus the integral of, with the same limits, v times du dx. So v is minus half cos 2x times 2x dx. So this one gets cancelled out. And let's simplify everything in the brackets. So this one minus half x squared cos 2x pi over 6 and 0. And the negative sign we can bring outside, then this will become plus the integral of pi over 6, 0, and x times cosine 2x dx. All right, so just substitute the limits into there, then we get minus half times pi over 6 squared times cosine 2 times pi over 6, that is pi over 3, minus negative half times 0 squared. So if anything with 0, this just becomes 0. So this just minus 0 plus the integral of this. Okay, this integral we will solve later using integration by parts again. So we'll leave it at this. Okay, so simplifying, you would get minus pi square over 12, and then cosine pi over 3, that is half, plus integral of pi over 6 and 0, x cos 2x dx. And this would be the integral of pi over 6, 0, x cosine 2x dx minus pi square over 24. Yeah, so this is our intermediate expression, not our final answer. To get the final answer, we need to evaluate this integral that we have here. Yeah, so this integral, it's again a product of two functions. So to figure that out, we need to do integration by parts again. So using our Lie rule, you can see that we need to make u equals to x and cosine 2x to be our dv dx. So now du dx would be equal to 1, and v would be equal to sine 2x times 1 over the derivative of 2x, which is half. So v is just half sine 2x. Okay. All right. So let's evaluate the integral. So we have u times v, which is x times half sine 2x. So you just get half x sine 2x with respect to the upper and lower limits, minus v times du dx. V times du dx is just half sine 2x times 1, which is just half sine 2x dx. And the limits are pi over 6 and 0. Okay, let's continue over the next page. So substitute half x sine 2x. You would get half times pi over 6 sine 2 times pi over 6, which is pi over 3, minus half times 0. So automatically it just becomes 0. Okay, and then minus, can take out the half in this case, so minus half integral of pi over 6, 0, sine 2x dx. Okay, so simplifying, you get pi over 12 sine pi over 3. That is square root 3 over 2 minus half integral of sine 2x. That's just minus cos 2x divided by 2. So minus half cosine 2x. So pi over 6, 0. So simplifying, you get square root 3 over 24 pi minus half bracket minus half cosine 2 times pi over 6, so pi over 3 minus negative half cosine 2 times 0, or cosine 0. So I'll just simplify all this using my calculator. So minus half cos 60 minus negative half cosine 0. Just get 1 over 4. So you get square root 3 over 24 pi minus 1 over 8. So this is our integral of x cos 2x dx. Okay, now we can find our final answer, which is square root 3 over 24 pi minus 1 over 8 minus pi square over 24. Yeah, I don't think we can simplify any further, so we can leave our answer as this. Yeah, so yeah, this would be our final answer for this entire question. If you want to check whether your integration is correct, just type this exact integral into your calculator, if your calculator supports that, and see if you get this exact answer. Okay, so with that, let's head on to the next question. Okay, so before I start this question, I realized I made a minor calculation error in the previous question. So here, I mistakenly wrote that pi over 6 squared times negative half is pi squared over half. So pi over 6 squared, that's pi squared over 36, times negative half, that is actually pi squared over 72. And hence here we would get minus pi squared over 144. So yeah, this would be square root 3 over 24 pi minus 1 over 8 minus pi squared over 144. So yeah, that's it. Let's continue on to the next question. Okay, so for this question, we are told to solve this complex equation, and we have to give our answers in the form x plus iy, where x and y are real. Okay, so first of all, to solve any complex equation, we first have to let, z be x plus iy. And then after we have done completely manipulating and expanding everything, we should separate the real and imaginary parts and equate the unknown real part to the known real part, and the same for the imaginary part. So let's start. So 5z, so 5 times x plus iy over 2 minus I times z conjugate. So z is x plus iy. Z conjugate is just x minus iy plus 20 plus 8. So since this is known, we're going to just move it to the other side. So this will become equals to minus 20 minus 8i. Okay, so now let's expand everything out. So expanding the numerator, you get 5x plus 5yi over 2 minus I. And then minus x plus iy times x minus iy, you would get x squared. I'm using the differences of square here. So x squared minus iy squared. So iy squared, you get I squared times y squared. Then we equate it to minus 20 minus 8i. Okay, so let's rationalize this complex fraction. So to do that, we need to multiply both the numerator and denominator by the conjugate of the denominator. So since our denominator is 2 minus I, the conjugate would be 2 plus I. So we'll multiply 5x times 5yi with 2 plus I. Do the same for here, 2 minus I times 2 plus I. And then this one would just be x squared minus I squared, that's just positive, so positive y squared equals to minus 20 minus 8i. Okay, so expanding this, you get 5x times 2 plus I plus 5yi times 2 plus I. And then the denominator, it's in the form a minus b times a plus b, so we can use our differences of squares. So 2 squared minus I squared. So 2 squared is just 4 minus I squared. That is minus negative 1, which is just plus 1. And minus x squared minus y squared equals to minus 20 minus I. Okay, so 4 plus 1, that's just 5. So we can, okay, you know what? Let's just expand everything out first. So 5x times 2, that's 10x plus 5xi plus 5yi times 2, that's 10yi. plus 5yi times I, that's 5yi squared. So I squared is minus 1, so you get minus 5y over 5 minus x squared minus y squared equals to minus 20 minus 8. Okay, so let's factor out 5 from the numerator and combine the real and imaginary parts. So factoring out 5, you get 2x minus y plus I times x plus 10y divided by 5, that is 2y over 5y over 5. So these cancel out and you get minus x squared y squared minus 20 minus 8. So you get 2x minus y plus I times x plus 2y minus x squared minus y squared minus 20 minus 8i. Okay, so we're going to now combine the real and imaginary parts. So our real part is 2x minus y minus x squared minus y squared plus I times x plus 2y equal to minus 20 minus 8i. Okay, so now we're going to equate the known real parts and known imaginary parts with the unknowns. So we can equate x plus 2y with negative 8. So that's our first equation. X plus 2y is negative 8. Then you would get x is equals to negative 8 minus 2y. So this is our first equation. And our second equation is 2x minus y minus x squared minus y squared equals to negative 20. So this is our second equation, and we'll sub. Let me see. Oh, we have 2 pages. So sub first equation into the second one. Okay, so 2 times x, so 2 times minus 8 minus 2y minus y minus x squared. So x squared is minus 8 minus 2y squared minus y squared equals to minus 20. So 2 times minus 8, it's minus 16. 2 times minus 2y is minus 4y minus 4y minus negative 8 squared, that is 64 minus 2 times negative 8 times 2y plus 2y squared, which is 4y squared minus y squared equals to minus 20. Okay, so I'll just simplify everything. So minus 16 minus 5y minus 64. 16 times 2y, that's plus 32y plus 4y squared minus y squared. Okay, I'll move the negative 20 over here, so plus 20 equals to 0. Okay, so minus 16 plus 20. Okay, that's just 4, so minus 5 minus 64 minus 32y minus 4y squared minus y squared, 20 minus 16, that is 4, equals to 0. So simplifying all the like terms, so minus 5y squared minus 37y minus 64 plus 4, that's minus 60, equals to 0. So let's multiply the whole equation by negative 1, and we'll get 5y squared plus 37y plus 60 equals to 0. So this is our final quadratic equation. Now we can try to solve this. So I'll try factorizing it. Okay, so we get 5y plus 12 times y plus 5 equals to 0. Okay, so solving each of these factors, first answer we get is 5y equals to negative 12, and y is negative 12 over 5. Second answer is y plus 5 equals to 0, and you get y equals to negative 5. So these two are our y's, our imaginary parts. Now we need to find the respective values of x's. So we're going to sub back into equation 1. So we're going to sub these into 1. Okay, so we get x is minus 8 minus 2y. So minus 8 minus 2 times y. So minus 12 over 5. You will get minus 8 times minus 2 times negative 12 over 5. Negative 16 over 5. And then we'll do the same for here. So it's minus 8 minus 2y. So my negative 2 times negative 5, that's 10. 10 minus 8, that is 2. Yeah, so this is our corresponding value of x and y. So yeah, these would be our final answers for this question. Now we can write down our complex numbers. So z is x plus iy. So the first set, we have minus 16 over 5 minus 12 over 5i. And the second one would be x is 2, y is minus 5i. So yeah, these two would be our final answers for this entire question. If you want to check whether you're correct, you can, set your calculator to complex mode and substitute these exact complex numbers into this equation. If you get 0, yeah, you're good to go. So yeah, with that, we'll move on. Okay, so for this question, we are told that the curve with this equation has a stationary point at x equals to p. So for the first part, we need to show that p satisfies this equation. Okay, so whenever you see the word stationary point, you should immediately think that, okay, dy dx equals to 0. So that's what we're going to do. So let's find dy dx first. So you take the derivative of e to the power of negative 5x ln 5x. So yeah, this function, since it's a product of two functions, we have to use our quotient rule in here. So what I like to do, instead of looking at the formula, I prefer think of it as this way. So we keep the first term first, and we multiply it by the derivative of the second term. So derivative of second term for ln is just f prime x over x. So x is 5x, so f prime would be just 5. So 5 over 5x. And then we add it with the derivative of the first term. So the derivative of the first term, derivative of anything to the e to the power of minus 5x, you keep your exponential, and then you multiply it with the derivative of the power. So you differentiate the power with respect to x, you get minus 5. And then you multiply it with the original second function. Okay, so simplifying, we will get 1 over x times e to the power of 5 over x, because this one, e to the power of negative 5x, we can rewrite as 1 over 5x. And then this one would be 5 times e to the power of negative 5x ln 5x. Okay, so now we'll equate our dy dx with 0. So minus 5 e to the power of negative 5x ln 5x equals to 0. Okay, let's move this over to the other side. So 5. So this we can re-express as 1 over e to the power 5x. So this is 5 ln 5x times 1 over e to the power 5x. Okay, so all right, what should we do? Okay, let's just cross multiply both of the equations. That's pretty pointless. Okay, let's just sub x equals to p. Okay, so cross multiplying, you get e to the power 5p equals to p times e to the power 5p uh times 5 ln 5p. So e to the 5p we can cancel out in here, all right? And then we can move the p and 5 over to the other side, all right? So we'll have 1 over 5p equals to ln 5p. So the reason why I cancel out e to the power 5p is because e to the power 5p cannot be equals to 0. So that's how you can cancel it out. So hence just swap these around, then you would get the exact result that you have to show. So I can write shown here and move on to the next question. Okay, so here they told us by sketching a suitable pair of graphs, show that the equation in part A has only one root. Okay, so to determine what graphs we need to sketch, just look at both sides of the equation, and we can straight away tell we need to sketch y equals to ln 5x or p, and y equals to 1 over 5x. So these are the two graphs we're going to sketch. Yeah, so let's put our axes. This is the x-axis and this is the y-axis. Let's draw ln 5x now. So to draw ln graphs, for ln we need to know that the y axis is our asymptote. Okay, because ln of, wait, never mind. Okay, what I meant to say is, yeah, so the y-axis cannot be asymptote because, x cannot be equals to 0, otherwise we have ln 0, which is obviously not possible. Yeah, so, and this would be going upwards. If you do a table of values and substitute 1, 2, 3, you'll see it starts to increase. So it'll be something like this. So this is y equals to ln 5x. Now let's sketch y equals to ln 1 over 5x. So this is just a reciprocal function that has been stretched in the y direction by scale factor 1 over 5. So if you know how to sketch 1 over x, you should be good here. So 1 over x, we know it's something like this. So both the x and y asymptote, both the x and y axes are asymptotes, and then we also have a negative wing here. Yeah, so this is y equals to 1 over 5x. And we can see there's only one point of intersection. So we can state, since one point of intersection, only one root. So yeah, this would be a final answer for this part. Let's head on to the following part. Okay, so for this part, we have to show by calculation that P lies in this range between 0.2 and 6. All right, so to show that, how I like to do is to take the original equation and make one side equals to 0. So we get ln 5p minus 1 over 5p equals to 0. All right, and now we're going to be subbing in the upper and lower values. So I will sub in p equals to 0.2. Okay, so just substitute it in, type it into a calculator. So ln 5 times 0.2 minus 1 over 5, 0.2. You would get exactly -1, which is less than 0. Okay, so now we'll sub p equals to 0.6. And I'm expecting to get a positive value. Then we can show that since there's a sign change, the root has to be within this range. Okay, so 6. Oh, okay. Yeah, we got a positive value, 0.765 to 3SF, which is more than 0. So you can clearly see that the sign changed, or the number turned from negative to positive. So we can say that since there's a sign change, P lies between 0.2 and 0.6. So yeah, we can write shown here. Yeah, with that, let's head on to the final part. Okay, so here we are told that the equation part A can be written in this form. Yeah, so they just, make P the subject, where this notation just denotes e to the power of x. Okay, so we need to use an iterative formula based on this rearrangement to calculate P corrected 2 decimal places, and each iteration should be given to 4 decimal places. Okay, so from this rearrangement that they gave us, it should be pretty obvious what our iterative formula, what our iterative formula should be. So it should be P subscript n plus 1 equals to 1 over 5 e to the power of 1 over 5 pn. Yeah, so let's start with an initial value. So for me, what I like to do is to take the midpoint of the range that P is in. So 0.6 plus 0.2, you get 0.4. That's your midpoint. So this is a value I like to start with. And to do this type of question, you should set your initial value as the answer in your calculator, and then you should substitute the answer, not the initial value, into your iterative formula. You should type into calculator first, and then you substitute in, and you press the equals button. You'll get your first iteration. So the first iteration for this, I got 0.3297 to 4 dp. And then to get your next iteration, press it one more time. So to know when to stop, if your values are very close together and when you correct them to 2 dp, the last 2 iterations are the same, you can stop there. Right? So yeah, for now, we don't think we're even close to that. All right, so I'll just do it again. So 0.3450. So what I like to do is I like to make sure my iterations are exactly the same, corrected to 4 dp, like my last 2 iterations. Okay, so next one, 0.3571. And then we have 0.3501. Okay, I can see we're starting to hover around the 0.35 range. Okay, we got 0.3541. Yep, we're getting closer and closer. It's probably a 0.52, 0.3518. Okay, and then P9, 0.3531. Okay, so one more iteration and I'll stop. Okay, 0.3523. Yeah, as you can see, the last two iterations are very close. And when we round them off to two decimal places, we get 0.35 for both of them. So even though they're not exactly the same, they're still very close. So hence, we can say that E is equals to 0.35, correct to two decimal places. So yeah, this would be our final answer for this part as well as the entire question. Let's head on to the next question. Okay, so for this question, we are told that the line L1 passes through this point 3, 1, -6 and is parallel to the vector 2i plus j plus 4k. Okay, and then it also says the line L2 passes through this point -1, 3, -6 and is perpendicular to this vector 3i minus 2j plus k. And the direction vector for L2 with the direction vector for L2 has no component in the x direction. So in other words, they're saying our I value is 0, or in column vector form, the very top value is 0. Okay, so for the first part, we need to write down a vector equation for L1 and find a vector equation for L2. Okay, so let's start with L1 first. L1 is pretty straightforward. So the vector equation, if you don't remember, it consists of a point on the line. So in this case, they already gave us the point 3, 1, -6, so we can write it down. And this would be added with a direction vector of L1. So what a direction vector is, it could be any vector that is parallel to the line. So in this case, they already gave us such vector, which is 2i plus j plus 4k, which is just 2 and 4. So that's our direction vector. And in front of the direction vector, we're supposed to put a scalar, so we can put lambda. So yeah, this would be our vector equation for L1. Now let's find for L2. So for L2, we are given a point that passes through it, so that's checked. But we are not directly given the direction vector of L2. Like we're not given a vector that is either on or perpendicular. I'm parallel to that vector. We're only given the vector that is perpendicular. So what do we do in this case? All right, so to find the direction vector, okay, we're just going to use this info, so no component in x direction, so we can let direction vector be, so since there's no component in x direction, the top x component would be 0, and then the remaining ones would be y and z. And we can use our scalar product since they're perpendicular. We know that when two lines are perpendicular, the scalar product will always equal to 0. If you want to know why, check the formula that they give in the formula list. So we'll multiply with this vector. So 3, -2, 1, dotted with 0, y, z equal to 0. So 3 times 0, that's 0, plus -2y, that's just -2y, plus 1 times z, which is z, equals to 0. And now we just make z on its own. You would get z equals to 2y. Yeah, so this is our solution here. So hence our direction vector, we can rewrite it as 0, y, 2y. And if we divide all the terms by y, our simplified version be 0, 1, and 2. So this is our direction vector. So now we can write down a vector equation. So a point that passes that is on L2, -1, 3, -6. So -1, 3, -6. Yep. Plus the direction vector times the scalar. In this case, I'm going to call it mu. So direction vector 0, 1, and 2. So yeah, you can leave your answers in column vector form for the vector equations as well as IJK form. So yeah, let's head on to the next part. Okay, so for this second part, we are told to calculate the acute angle between L1 and L2. Okay, so to do that, uh, we have to use our scalar product, all right? So we would only use the direction vectors for L1 and L2. So our scalar product here states that A dot B is equals to the modulus of A, which is the length of A times the length of B times cosine theta, where theta is the angle between them. So let's do it. So L1 dotted with L2, that is 214 dotted with 0, 1, 2. You'll get 2 times 0, which is 0, plus 1 times 1, which is 1, plus 4 times 2, which is 8. And that would be equals to 9. Okay, now we would find out what our modulus of L1 times modulus of L2 is. So modulus of L1 is square root of 2 squared plus 1 squared plus 4 squared times the modulus of L2 is 0 squared plus 1 squared plus 2 squared. So 2 squared plus 1 squared plus 4 squared, you get square root 21 times square root 0 squared plus 1 squared plus 2 squared, which is square root 5. And you would get square root 105. Yeah, just square root 105. Yeah, so now we can find our cosine theta, which is just L1 dotted with L2 divided by modulus of L1 times modulus of L2. So you get 9 over square root 105. So how do we know that this theta that we're finding, or we're going to find by taking the inverse cosine of this, is acute? So if it is positive for cosine, we can be certain it's acute because again, like if you remember your trig, everything in the first quadrant where everything is positive, all the ratios are positive, including cosine. Yeah, whereas in the second quadrant, where all the obtuse angles are, cosine is negative, only sine is positive. All right, so that's how you make sure about that. So we can, in this case, we can just directly take cosine inverse. And as for the unit, I don't think it really matters. You can use degrees or radians, whichever you like. So for me, I'm just going to use degrees in here. Yeah, so you would get 25.6 degrees to 1 decimal place. So yeah, this would be our final answer for the second part. Let's head on to the next part. Okay, so for the final part, we need to find the position vector, which is basically the coordinates of the point of intersection of L1 and L2. Okay, so to find the points of intersection between two lines, we need the vector equations of them first. So let's do for L1. So for L1, we already found in the previous part, 3, 1, -6 plus uh, um, lambda 214. Okay, so now what we'll do is we will expand this out and express this as just one column vector. Because if you don't know, the vector equation of a line, it basically just represents any generic point that could be that lies on the line. Okay, so you can think of the vector equation of a line as such. Yeah, so 3 plus lambda times 2, so 2 lambda, 1 plus lambda times 1, so 1 plus lambda, and negative 6 plus 4 lambda times 4, so negative 6 plus 4 lambda. Okay, so let's do the same for L2. So L2 is here for mu, so negative 1, 3, negative 6 plus mu 0, 1, 2. So expanding minus 1 plus mu times 0, just negative 1. 3 plus mu times 1 is just mu plus 3. Negative 6 plus mu times 2 is just 2 mu minus 6. So these are the column vectors of any generic point along these two lines. So to find the point of intersection, we just have to equate these two column vectors to each other, okay? All right, so to do that, you have to equate like the x coordinate of one with the x component of the other one. So let's equate 3 plus 2 lambda with negative 1. I'm sorry, I don't know what's... Okay, so 3 plus 2 lambda equals to negative 1. Then we'll get 2 lambda equals to negative 1 minus 3, which is negative 4. And then lambda would be negative 4 divided by 2, which is negative 2. So this is the value of lambda. Okay, now we can substitute back into our equation for L1 to get the position vector. So position vector would be 3 plus 2 lambda, 2 times negative 2, 1 plus negative 2, so 1 minus 2, and minus 6 plus 4 times negative 2. So with that, you get 3 minus 4, which is negative 1, minus 2 plus 1, which is also negative 1, and minus 6 minus 8, which is negative 14. So yeah, this would be our position vector, which is basically the coordinates of our point of intersection of L1 and L2. So yeah, with that, let's head on to the next question. Okay, so for 10a, we need to express this fraction in partial fractions. So first things first, to express this in partial fractions, we need to factorize our denominator. So factorizing it, to factorize it, we need to realize that it's actually in the form a squared. So 1 square minus b square. So b is 3y. Because b square, 3y square is just 9y square. So this is a minus b, which is 1 minus 3y times a plus b, 1 plus 3y. Okay, now we can rewrite it in the fraction. So 2 over 1 minus 3y times 1 plus 3y. Okay, so to split this into partial fractions, first make sure that the degree of the numerator is less than the degree of the denominator, which it is in this case. The denominator is 2, and for the numerator is 0. So we can begin the decomposition. So this is going to be a over 1 minus 3y. Since this is a linear factor, our numerator is just going to be a constant. Same for the next one, b over 1 plus 3y. Okay, so now we're going to multiply both sides by the numerator of our left-hand side. I'm sorry, the denominator of our left-hand side. So this would be 2 equals to a times negative 3y cancels out. So you just get a times 1 plus 3y. And then plus b times 1 plus 3y cancels out. So you just get b times 1 minus 3y. Okay, so now we are supposed to make either one of these factors equal to 0 by substituting an appropriate value of y. So let's make this 0, 1 minus 3y. And if you solve this equation, you equate it to 0, you'll get y equals to 1/3. So we're going to substitute y equals to 1/3. So this one, since it'll be 0, b would be gone. So we only have to solve for a. So a times 1 plus 3 times 1/3. So 3 times 1/3, that's 1. So 1 plus 1 is 2. And you make it equals to 2. You will get a is equals to 1. Okay, so now that we made this 0, we have to make this factor 0 as well. So to make this 0, if you solve it, like you make it equal to 0, you'll get y equals to negative 1/3. So now we'll substitute y equals to negative 1/3. Okay, so since this will be 0, a would be gone, so we'll only have b times 1 minus 3 times negative 1/3. That would give you 2 equals to 2. Hence, b would be equals to 1. Okay, let me double check that. Okay. Yeah, that would be 2. So b would be equals to 1. Hence, we can say that 2 over 1 minus 9y squared is a, which is 1 over 1 minus 3y, plus b, which is 1 over 1 plus 3y. So yeah, this would be our final answer for this first part as well. For the first part, let's head on to the next part. Okay, so for the second part, we are told the variables x and y satisfy this differential equation that they gave us here. And we're also given the initial conditions that y equals to 0 when x equals to pi over 12. So we need to solve the differential equation and obtain an expression for y in terms of x. So our final answer, y has to be the subject. Okay, so first things first, to solve a differential equation, so we'll copy it down first. We need to separate the variables. Okay, so we move all the y terms in here, since dy is the numerator. And for dx, we move it to the other side and move all the x terms there. So let's divide both sides by 1 minus 9y squared. You'll get 2 over 1 minus 9y squared dy. And as for dx, we should divide both sides by cos squared 3x. And dividing by cos squared 3x is the same as multiplying by secant squared 3x. So these are the two expressions we need to integrate. So on the left-hand side, if you realize, the expression we have to integrate is the exact same expression that we decompose into partial fractions. So let's rewrite it. So 1 plus over 1 minus 3y plus 1 over 1 plus 3y dy. And to integrate secant squared 3x, we know that when you differentiate tangent x, you get secant squared. Hence, when you integrate secant squared, you get tangent squared. So you will get tangent 3x. And you also need to you also need to divide by the derivative of the inner function, which in this case is 3 squared. So you have to divide by 3. So this is 1/3 tangent 3x plus c. Okay, now let's integrate this. So to integrate this, we will start with 1 over 1 minus 3y first. So to integrate this type of rational function, we have to make it in the form of f prime x over fx, since the degree of the denominator is more than that of the numerator. So, oh gosh. Okay, so to make that, so when you differentiate 1 minus 3y with respect to y, you'll get minus 3 over 1 minus 3y. And to, keep the value the same, you actually have to multiply by -1/3. So this is -1/3 times -3 over 1 minus 3y. And as for this, same thing, you differentiate the denominator and you replace the numerator with the derivative. And as to ensure the value remains the same, you divide by whatever number you put there. So -1/3. Okay. All right. So to integrate, you ignore whatever scalar you have in front. So you keep that alone and you only integrate the fraction in the bracket. So minus this and this. So it's in the form f prime x over fx. So hence, according to a formula sheet, it'll just be ln of fx. So -1/3 ln of minus 1 minus 3y. Same for this. Keep the scalar and just integrate whatever is inside the bracket. So this one's also in the form f prime x. So this should just be ln 1 plus 3y. Okay, and then this would be 1/3 tangent 3x plus c. Okay, so we can see that almost all the terms we found, they have the coefficient 1/3. So since I don't like fractions, I'm just going to multiply both sides of the equation by 3. So we'll get ln, and then I'll also swap these two terms because I don't like having negative signs in front. But that's just my personal preference. You can keep them if you're okay with it. So minus ln 1 minus 3y equals to tangent 3x. And for the c, you don't have to write 3c because you're just multiplying a constant with another constant. So just be a new constant called b, or whatever letter you would like to use. Okay, so for the left-hand side, we can see that it is in the form ln a minus ln b. And we know that this is always equals to ln a over b. So hence we can rewrite this as ln 1 plus 3y over 1 minus 3y. And this is equals to tangent 3x plus b. Okay, so to find b, we need to use our initial conditions in here. So which says sub x equals to pi over 12 and y equals to 0. Yeah. So you get ln 1 plus 3 times 0, that is 1. And then 1 minus 3 times 0, that's also 1. So 1 divided by 1, that'll just be 1. So you get ln 1 equals to tangent 3x. So 3 times pi over 12. That is just pi over 4 plus b. So ln 1 is 0. Pi over 4, that is 1. So plus 1 plus b equals 0. Well, actually, let me check. Yeah, pi over 4. Pi divided by 4, yes, 1. So b, we would get -1. So hence we can rewrite so we get our full expression as such. Okay, so now what we have to do is to obtain an expression for y in terms of x. So we need to make y the subject. So to do that, let's first take e on both sides. So this cancels out. So we'll only have the expression inside the ln. So 1 plus 3y over 1 minus 3y equals to e to the power of tangent 3x minus 1. Now we will multiply by the numerator. So the denominator, okay, to get rid of the denominator. So this would be e to the power of tangent 3x minus 1 times 1 minus 3y. Okay, and then we'll get 1 plus 3y equals to e to the power of tangent 3x minus 1 minus 3y e to the power of tangent 3x minus 1. Okay, now we'll move all the y terms to the left-hand side and all the other terms to the right-hand side. So you get 3y plus 3y times e to the power of tangent 3x minus 1 equals to e to the power of tangent 3x minus 1 minus 1. And now let's factor out y. So y3 plus 3e tangent 3x minus 1 equals to e to the power of tangent 3x minus 1 minus 1. So just divide both sides by this bracketed expression to get your final answer. E to the power of tangent 3x minus 1 minus 1 over 3 plus 3e to the power of tangent 3x minus 1. So yeah, this would be a final answer for this entire question. If you want to check whether your answer is correct, just type in the initial conditions into this expression and see if you get them exactly. So yeah, with that, let's head on to the next and final question. Okay, so for this question, we are given a diagram that shows the graph of y equals to secant squared, square root 3 plus 2 tangent x for this domain of x between pi over 4 and negative pi over 4 and the minimum point m. So for the first part, we need to find the x coordinate of m. Okay, so since m is a minimum point, immediately you should think, oh, stationary point. So dy dx is equals to 0. So let's evaluate our dy dx. So to find your dy dx in here, yeah, you can see that this function is not a very nice function. It's in fact a product of two other functions. So in this case, we have to use our product rule. Okay. So yeah, I'll do it the same way as I did before. Keep the first term. And then you multiply by the derivative of the second term. So to get the derivative of square root 3 plus 2 tangent x, you take the power, you bring it down, keep the expression inside, and minus 1 from the existing power. So you'll get to the power of minus half. And then you multiply by the derivative of the inner function, which in our case is 3 plus 2 tangent x. So you would get 2 secant square x, because 3 would just be 0 and 2 tangent x gives you 2 secant square x. So these two cancels out. Okay, we'll simplify later. Okay, and then you add it with the derivative of the first term, which is secant square x. So let's use chain rule. So bring down the old power and minus 1 to get the new power. So 2 secant x. But we're not done here yet. Now we need to multiply by the derivative of the inner function, which is secant x. So to get the derivative of secant x, one way you can do is to re-express secant x in terms of 1 over cosine x and then work your way from there using your quotient rule. But there's a more efficient method is just go to your MF19, go on the differentiation. You would see that they give the differentiation formula for a list of functions, including secant x. And the derivative of secant x just happens to be secant x times tangent x. So yeah, whenever you're dealing with these questions, you have to be familiar with your formula sheet. Okay, like that's also a part of the parcel and at being good at math. It's not just that, oh, you have to be smart. You also need to know how to use your resources smartly. Okay, so anyway, now we keep our second term. So we multiply by square root 3 plus 2 tangent x. Okay, now we'll simplify everything. So secant squared times secant squared, that is secant x to the power 4 over, so this is the same as 1 over square root 3 plus 2 tangent x. So it becomes secant to the power 4x over 3 plus 2 tangent x. And then plus 2 secant x times secant x, so 2 secant square x tangent x square root 3 plus 2 tangent x. Okay, so now we'll make it equal to 0 of dy dx. So this whole expression equals to 0. Plus 2 secant square x tangent x square root 3 plus 2 tangent x equals to 0. Okay, so to get rid of this square root here, we can just multiply the both sides of the equation by this denominator so that we get rid of this denominator and the square root. So doing that, we get secant 4x plus 2 secant square tangent x times 3 plus 2 tangent x equals to 0. Okay, now we'll expand out everything. Okay, we have a bit more space. Okay, so we'll expand everything and factor out whatever we have after expanding in like common. Oh, so 2 times secant square tangent square times 3. This one will be 6. And then plus 2 tangent x, so you get 2 times 2, that's 4. Secant square x, tangent x times tangent x, you get tangent square x equals to 0. So yeah, here in our equation, we can see that secant 4x is a common, factor. So we can factor that. No, I mean secant square is a common factor, so we'll factor that out. So factoring that out, we get secant square. We get secant square plus 6 tangent x plus 4 tangent square x. Okay, so everything in the bracket, almost everything is in terms of tangent and tangent square. So the secant square, we also need to change in terms of tangent. And luckily for us, we do have an identity that relates tangent square and secant square, which is this. So secant square is just 1 plus tangent square. So secant square x. So this is 1 plus tangent square x plus 6 tan x plus 4 tangent square x equals to 0. And then you get secant square x times tangent square plus 4 tangent square, you get 5 tangent square plus 6 tangent x plus 1 equals to 0. Okay, now we have to equate both of our factors to 0. So secant square x equals to 0. You'll get secant x equals to 0. But if you make secant, like if you put secant x as 1 over cos x equals to 0, obviously there won't be any valid solution on that, so we'll have to reject this. Okay. So our only option is this quadratic in terms of tangent. So 5 tangent square plus 6 tan x plus 1 equals to 0. So let's try to factorize it. Okay, so we got 5 tan x plus 1 times tan x plus 1 equals to 0. Now let's solve both of them. So 5 tangent x plus 1 equals to 0. You will get 5 tangent x equals to -1, and tangent x equals to -1/5. And as for this one, you will get tangent x plus 1 equals to 0, and tangent x equals to -1. So we have two values of tangent x. So let's look at where m is. So m is between -π/4 and 5/4. So for this one, if you take x as tangent inverse -1, you will get -π/4. Okay, so as I said, m is between π/4 and -π/4, so we'll reject this. So this is our only option available. So since this tangent x value is negative, so using our unit circle, so our unit circle would cover from π/4 to -π/4. So -π/4 is from here all the way to here. So it only covers these two. So this A and C. So A is positive for tangent and this is negative for tangent. So hence, our x would be in this fourth quadrant. So it would be a negative acute angle. Okay, so to get it, just take tangent inverse -15, -1/5. And you should get, don't forget to put your answer in radians because our domain is in radians. You would get -0.197 to 3SF. And this would be our x coordinate for m. And so we can head on to the next question, next part. Okay, so for this part, we are told using this substitution, u equals to 3 tangent 2x, we need to find the exact value of the area of the region bounded by the curve, the x-axis, and the lines x equals to -π/4 and x π/4. So in case that's like too many words for you, so visually, they're just asking for the area under the curve in this diagram. So our limits would be π/4 and -π/4. Okay, so let's write down our integral. Okay, so the limits will be π/4 and -π/4, and our integral would just be the equation of the curve. So that's secant square. Sorry, secant square times square root 3 plus 2 tangent x dx. Oh no, what just happened? Okay. Yeah, so this is our integral that we have to evaluate. So now we're ready to do the substitution. So u equals to 3 plus 2 tangent x, and du dx would just be, so derivating 3, you get 0. So 0 plus derivative of 2 tangent x. So you keep the 2 alone and you differentiate tangent x only. So you get 2 secant square. So let's just make secant squared dx the subject. So divide by 2 on both sides and multiply by dx on both sides. You get du over 2 equals to secant squared dx. Yeah, okay. And since we're dealing with a definite integral and we're using integration by substitution, we also need to change our limits. So the upper limit would just be 3 plus 2 tangent π/4. So π/4, that is, tangent π/4 is 1. So 3 plus 2 is 5. And then the lower limit would be 3 plus 2 tangent -π/4. You would get the 3 minus 2, which is 1. Yeah, so these two will be our new limits. So now we're ready to integrate. So 5, 1, uh, square root u over 2 du. Since secant squared dx is du over 2, you can move the 2 in here and you can have du in here. Okay, so now to integrate this, you move the half out of here and you change square root u to the power of half du. So this should be no problem integrating. So integrating this, you just add 1 to the power, you get u to the power of 3 over 2, and you divide by the new power, 3 over 2. And then you get 5 and 1. And this would be half times 5 to the power of 3 over 2 times 2 over 3 minus 1 to the power of 3 over 2, which is just 1. So 1 divided by 3 over 2, you just get 2 over 3. Okay, so to evaluate what 5 to the power of 3 over 2 is, let's rewrite that. So 3 over 2 is the same as 1 plus half. And let's split that up using our law of indices. That's the same as 5 to the power of 1 times 5 to the power of half. So 5 to the power of 1 is 5, and 5 to the power of half is 5 square root 5. So rewriting that, you would get 5 square root 5. Oh, sorry, that wasn't too nice. Times 2 over 3 minus 2 thirds. Okay. Then you would get yeah, so we can factor out thirds. Okay. Half 3 10 square root 5 minus 2. And then you divide, and then you factor up 2 from the numerator. So 5 square root 5 minus 1 over 3. Yeah, so you would get 5 square root 5 minus 1 over 3 as your final answer for the area. So we can stop here. So this would be our final answer for this question as well as the entire part. So we have come to the end of this paper. So I hope you found this video helpful. If you did, please make sure to like and subscribe to this channel and share it with anyone who might find this types of videos helpful. If you have any feedback, any questions, or any future video ideas, leave them down in the comments below, and I'll see you guys again next time. Okay, thank you.